All right, so we're going to do this problem here, the overhead version now. Okay. And we're seeing that we're going to keep a couple things constant in this problem. We're first going to keep the radial value to be 2 meters. That's the length of the rope. The second thing we're going to do is we're going to have the mass of the object still remain at 5 kilograms. But what we're going to do is we're going to add a little bit something. So when an object is spun overhead, it doesn't achieve perfect horizontal motion. And the reason for that is that you require an infinite amount of tension in that rope in order for that to happen. So even spinning it very, very fast, there is a small sag to it. But in this case, we're going to make the sag pretty significant. We're going to make it to be 30 degrees, my favorite angle. Okay? So what we're going to do first of all is we're going to do a free body diagram to look at everything that is in this problem. So looking at this, we're going to take my mass here, which is the bucket, and we have a downward force here that is equal to mg, the weight of it, and I have a tension that is in this direction. Okay? Those are my two forces. Now I'm going to say something else here is that, well, first of all, that only this portion of the tension is producing uniform circular motion. And this portion of the tension is counteracting the weight. Okay? So those two things are acting in that tension. Now, I do know how to find a lot of this stuff already, but what I really need to know is I need to know how much this tension is here in order, well, I need to figure out, sorry, my brain's a little flustered. I need to figure out what the velocity is. So in order to do that, I need to figure out what the tension is, and in order to do that, I need to be able to decompose it like this. So let's start over here with this part here. So looking at this, okay, I have my mg down, and my tension that is in the horizontal or in the vertical up, okay? And all of that is going to be equal to 0. There is no acceleration that is up or down. So we're going to set that to be equal to 0. Now for over here, this section here, there's only the tension in the x, and that is accelerating. There is this uniform circular motion, which means that there is a center pointing acceleration. Okay? Cool? Now let's look at the first part of this problem. Let's look at this mg minus t, and we're going to go through the process. So mg minus ty is equal to 0. And now what I need to do is I need to figure out what ty is. So in my original diagram, this right here would have been 30 degrees. So this right here is the opposite of that. So what I'm looking at is mg minus t. And if I'm looking at the opposite of that, I'm going to be dealing with what? Sine or cosine? Sine. The sine of 30 degrees is equal to 0. So I'm left with mg minus 1/2 t is equal to 0. Okay? Or mg is equal to 1/2 t, or 2mg is equal to t. Okay? So that means that the tension of the whole system is going to be 2 times the mass times the acceleration due to gravity. Okay? And we already knew the mass was 5 kilograms. We're going to say that our acceleration due to gravity is 10, even though we know it's 9.8. We're going to multiply that by 2. Okay? That gives me 50. 50 times 2 gives me 100. So that means that my tension is equal to 100. Cool? So that means that the total tension, this component of it, let me bring this back, this component of it right here is equal to 100. What I need is now this component. Okay? So with that in mind, I know that I have this to be 100. So I need to solve this. I know that this is a 90 degrees. So I am looking at an adjacent, and I also know that this is 30 degrees. So I can say that the cosine of 30 is equal to my adjacent of my hypotenuse So that's going to be my t in the x over my hypotenuse, or 100, can you still see that? Yep. Times the cosine of 30 is equal to tx. Okay? That turns out to be, if I remember right, the cosine of 30 is 0.86. So that means that tx is equal to about 86. Cool? Now for the last part of this calculation is that I have that tx, which I have right here, is equal to ma. So I said that tx is going to be 86 newtons. That's equal to my mass times my acceleration, which is 5 kilograms times a. I don't know what my acceleration is yet, but I can find it pretty easily, actually. So I get 86 newtons divided by 5 kilograms. Gives me a, and I'm doing this slightly differently than I did the last problem. And I know that because the object is moving in a circular path, that acceleration is going to be equal to v squared over r. Cool? And I already know that my r is 2. So I'm left with 86 newtons is equal to 5 kilograms, which is equal to v squared over 2. So lastly, I'm looking at 2 times 86 over 5 is equal to v squared. Can't do that calculation quite in my head. That's what, 12? 16, so I'll get 172 divided by 5 is equal to v squared. It's about 172. That's about 175. So I'm going to make this simpler on myself. So 175. So it's going to give me 3. 3 gives me 2. 2 gives me 5. So I'm getting, what? Do this quick. 5, 2, that's 5. So that gives me 35. About equals v squared. Just simplifying it. It's not quite 35. Okay, and then I'm going to take the square root of that, and that is going to give me the speed of that object. Cool? All right.